To understand artificial intelligence, we must go back, far back, even before computers existed. For thousands of years, humans have imagined mechanical beings that could think or act like us. In ancient Greece, myths told of Talos, a giant bronze man built to protect the island of Crete. In ancient China, inventors crafted wooden birds that could fly. And in the Middle Ages, alchemists dreamed of creating a homunculus, a tiny artificial human. These were myths, legends, and dreams. But the desire was the same. Humans wanted to create intelligence outside themselves. The real story of artificial intelligence begins in the 20th century. In the 1940s and 50s, massive machines, the first computers, were built. They were giant, room-sized, humming with wires and vacuum tubes. And then came a man named Alan Turing. In 1950, he asked a question that would change everything. Can machines think? Turing didn't just ask, he proposed a test. If a machine could carry on a conversation and fool a human into believing it was also human, then maybe, just maybe, it could be considered intelligent. This was the birth of AI as a scientific idea. In 1956, at Dartmouth College in the United States, a group of researchers gathered for a historic workshop. They believed that every aspect of learning and intelligence could, in principle, be described and simulated by machines. It was bold, it was ambitious, and it sparked a field that still drives innovation today. Of course, progress wasn't always smooth. The early decades of AI were filled with hope, but also disappointment. Computers of the time were slow, memory was tiny, and many promises proved too difficult. Researchers faced what we now call the AI winters, times when funding dried up, interest faded, and people declared that AI was a failure. But like all great ideas, AI never truly disappeared. With each new wave of technology, faster chips, bigger data, smarter algorithms, it came back stronger. And today, AI is no longer just a theory in a lab, it's part of your daily life. AI works in a very similar way. We give it examples, millions of them, and with each example, the AI adjusts its internal rules until it can say, yes, that's a cat, no, that's not. This system of learning from examples is called machine learning. It's the backbone of modern AI. Instead of being programmed with every rule, the machine learns rules on its own, from data. One of the most powerful approaches within machine learning is something called neural networks. AI works in a very similar way. We give it examples, millions of them, and with each example, the AI adjusts its internal rules until it can say, yes, that's a cat, no, that's not. This system of learning from examples is called machine learning. It's the backbone of modern AI. Instead of being programmed with every rule, the machine learns rules on its own, from data. One of the most powerful approaches within machine learning is something called neural networks. Inspired by the human brain, neural networks are made up of layers of tiny nodes, like digital neurons, each passing signals to the next. When you feed in data, each layer transforms it, searching for deeper patterns. At the start, it sees edges and shapes, then textures, then entire objects. Layer by layer, the network learns to see the world. Take language as another example. AI models like chatgpt don't just memorize words. They analyze patterns across billions of sentences, learning how words connect, how ideas flow, and even how emotions are expressed. This is why AI can now write essays, answer questions, or even hold conversations almost like a human. But remember, AI doesn't truly understand the way we do. It doesn't know what a cat is. It only knows patterns. It doesn't feel emotions. It imitates them. That's both its strength and its limit. Today, AI is powered by three main ingredients: data, oceans of information; algorithms, the rules and methods to process that data; computing power, the machines that crunch the numbers. When these three come together, AI can do remarkable things. For recognizing faces in photos, binary setup and difference, to translating languages, to predicting diseases. Let's imagine a simple AI conversation. Human: hello, AI. Do you know what the weather is today? AI: I don't truly know the weather, but I can access patterns in data. Based on reports, it's sunny in New York today. Notice, the AI doesn't actually feel the sun. It's not looking out a window, it's analyzing data and patterns.
You might think artificial intelligence is locked away in research labs or science fiction movies. But in truth, you use AI every single day, often without even realizing it. It's there when you relax in the evening, when you drive to work, when you shop online, even when you post on social media. AI has quietly woven itself into the fabric of modern life. Every time you open Netflix or YouTube, AI is at work. It studies what you've watched before, the genres you love, the videos you finish, the ones you skip. Then it makes a prediction. What's the perfect next thing for you to watch? That's why you can spend hours streaming, because behind the scenes, algorithms are feeding you recommendations tuned to your personal taste. Think about Google Maps. When you open it, you're not just seeing a static map. AI is analyzing real-time traffic data from millions of drivers, predicting where jams are forming, and guiding you along the fastest route. It's not just the map anymore. It's a prediction engine for the road. And then there are voice assistants. Siri, Alexa, Google Assistant. They've become part of our daily lives. You ask, "What's the weather today?" Or, "Play my favorite song." The AI listens, translates your speech into text, interprets the meaning, and answers in less than a second. It feels like magic, but it's actually layers of algorithms running at lightning speed. Even your email relies on AI. Every spam message you don't see, that's machine learning at work. It scans millions of emails, detects patterns of scams and junk, and filters them out before they ever reach your inbox. A quiet guardian, working invisibly, saving you from chaos. And then there's your camera. Modern smartphones don't just capture light. They use AI to enhance images, brightening colors, sharpening faces, even removing blur. Sometimes the photo you see isn't just what your lens captured. It's what AI thinks you wanted it to capture. In cars, AI is even more visible. Self-driving technology uses cameras, sensors, and GPS to analyze the world in real time. It detects pedestrians, reads traffic lights, and predicts the motion of other vehicles. In a split second, it makes decisions that could save lives. In healthcare, AI is becoming a doctor's ally. It can scan X-rays and MRIs with superhuman accuracy, spotting early signs of disease that even trained eyes might miss. For a patient, this could mean the difference between life and death. And for a doctor, it's like having a second set of brilliant eyes always on call. And of course, social media. Every post you see in your feed, every suggested friend, every ad is chosen by algorithms. These AI systems are designed to predict what will keep you scrolling, clicking, reacting. They don't just respond to your behavior, they shape it. This could mean the difference between life and death. And for a doctor, It's like having a second set of brilliant eyes always on call. And of course, social media. Every post you see in your feed, every suggested friend, every ad is chosen by algorithms. These AI systems are designed to predict what will keep you scrolling, clicking, reacting. They don't just respond to your behavior, they shape it. The truth is, you're already surrounded by AI. It's invisible, working in the background, guiding what you see, what you buy, even what you believe. We rarely notice it, but it's everywhere. Here's the key, though. Most of this is what we call narrow AI. Each system is specialized. One AI recommends videos, another finds the fastest route, another filters spam. They don't overlap. They don't generalize. Each has one job, and it does it very well. But together, all these specialized AIs already shape the modern world in ways we never imagined just a decade ago. Think about it. Personalized entertainment, instant navigation, smart assistance, fraud detection, medical analysis, all powered by algorithms humming in the background. Even search engines depend on AI. When you type a question, the algorithm doesn't just look for matching words. It tries to understand your intent, predicting what you meant to ask. That's why typing best pizza near instantly fills with your city's top spots even before you finish typing. Online shopping? Yep, AI again. Every click, every purchase you make is tracked and analyzed. The system learns your tastes and shows you products it predicts you'll want next. Sometimes, even before you realize you want them. Even the little things, like your phone's keyboard predicting the next word you're about to type, are powered by AI. It's as if your device is finishing your sentences. Financial institutions rely heavily on AI too. Banks and credit card companies use machine learning to spot fraud in real time. A suspicious transaction on your card? AI might freeze it instantly, protecting your money before you even notice. When you add it all up, AI already makes billions of decisions for us every single day. Most of the time, we don't even notice it's happening. It's silent, invisible, but it's there, shaping the flow of modern life. And as AI becomes more capable, its presence in daily life will only grow stronger. Not just shaping what we watch or buy, but influencing how we work, how we learn, how we connect with each other. AI isn't just a tool anymore. It's becoming a partner in our daily existence. The question is no longer, do I use AI? The question is, how much of my life is already guided by AI, and how much more will be tomorrow?
And forcing us to rethink what it means to be human in an age of intelligent machines. The mystery of how AI works is becoming clearer, but understanding the how is only the beginning. The bigger question is, what happens when AI grows more powerful? How will it transform our jobs, our societies, and even our understanding of intelligence itself? In the next chapter, we'll step into the future, exploring how AI is reshaping industries, redefining creativity. Otherwise, we risk trusting machines that look intelligent, but are making flawed or unfair decisions. And yet, even with these limitations, the progress is breathtaking. In just a few decades, we've gone from clunky rule-based systems to AI that can write essays, create music, translate languages, generate images, and yes, even hold conversations with you right now. The curtain has been pulled back. Together, these three ingredients form the recipe for modern AI. But AI isn't magic. It has limits. If the data is biased, the AI will be biased. If the data is incomplete, the AI will make mistakes. An algorithm is only as good as the information it's trained on. This is why transparency matters. We need to know how these systems are trained, what data they've seen, and where their blind spots might be. Used reinforcement learning. It played against itself millions of times, learning strategies that no human had ever thought of. That's the power of trial, error, and feedback at machine speed. So, to sum it up, AI works through data, algorithms, and computing power. Data provides the examples. Algorithms find the patterns. Computing power makes it possible to run billions of calculations in seconds. Another key ingredient? Reinforcement learning. Instead of learning from labeled examples, reinforcement learning is about trial and error, just like training a pet. Give a system a goal. Reward it when it gets closer. Penalize it when it makes mistakes. Over time, it learns to make better decisions. Google's AlphaGo, the AI that beat the world champion at the game of Go. From voice recognition to image generation to self-driving cars. But machine learning and deep learning are only part of the story. AI also relies on natural language processing, the ability to understand and generate human language. When you talk to Siri, or when a chatbot answers your question, it's using language models that predict the next word one step at a time based on everything they've learned from massive amounts of text. The first layer might detect edges, the next, shapes, another, textures. As the information flows deeper, the system builds a complete understanding. By the end, the network can say, yes, this is a cat, or no, it's not. And when these networks get really deep, with dozens or even hundreds of layers, we call it deep learning. Deep learning is what powers today's breakthroughs: edges, shapes, ears, eyes, fur, until finally it sees a cat and says with confidence, "That's a cat." This process is called machine learning. Instead of being programmed step by step, the machine learns from experience. And one of the most powerful techniques within machine learning is called neural networks, inspired by the human brain. In a neural network, information passes through layers of neurons. Each neuron is like a tiny decision maker. Show them enough cats, furry, whiskers, pointy ears, and they start to recognize the pattern. AI does the same thing, only instead of looking at a few examples, it might look at millions. The process starts with data: images, text, audio, video, sensor readings, anything that can be collected and stored. This data is then fed into an algorithm, a mathematical recipe that looks for patterns. Okay, we've seen how AI is everywhere in our daily lives, but let's pull back the curtain. How does it actually work? How do machines learn? How can an algorithm recognize a cat in a picture, predict the next word in a sentence, or drive a car? At the heart of AI lies a simple but powerful idea: learning from data. Think of it this way: a child learns what a cat is